Polynomials, the remainder theorem.
The remainder theorem. If we divide 14 by 3, we have 14 divided by 3 is 4 remainder 2. Notice that the remainder 2 is less than the divisor 3. We can write 14 divided by 3 is equal to 4 2/3. In the same way, if we divide a polynomial function of x by x minus a, we'll get another polynomial, g of x, and a remainder, which will be just a number. Now the reason it'll be a number is the remainder will be order less than the divisor, which is 1, so it will be just a constant. So we can write the function of x divided by x minus a is equal to g of x plus a remainder over x minus a. Now, if we multiply both sides by x minus a, we get the function of x equals x minus a times g of x plus the remainder. If we substitute a for x, we get the function of a is equal to, in brackets, a minus a times g of a plus the remainder, which is the function of a equals 0 times g of a plus the remainder. In other words, the function of a is equal to the remainder. So, the remainder theorem states, if a polynomial function of x is divided by x minus a, then the remainder is function of a. Now we can demonstrate this in an example. Part 1 says, evaluate x cubed minus 4x squared plus 3x plus 5 divided by x plus 2. In part 2, we have to use the remainder theorem to find the remainder and show both methods give the same remainder. So for the first part, we set out the division sum. Then we say x into x cubed. Now that goes x squared, and we write it on the top above the x squared column. Then we go x squared times x plus 2, and this gives us x cubed plus 2x squared. We subtract, the x cubes disappear, and we have minus 4x squared, take away 2x squared, so that's minus 6x squared. We bring down the plus 3x, and we divide x into minus 6x squared. Now that gives minus 6x, which we write on the top above the x column. We now multiply minus 6x times x plus 2, and that gives us minus 6x squared minus 12x. And we subtract. The minus 6x squareds cancel, and we have 3x take away minus 12x, which is 3x plus 12x, which is 15x. We then bring down the plus 5, and we divide x into 15x, which gives us plus 15. We write that on the top. We multiply plus 15 times x plus 2, and we get 15x plus 30. When we subtract, the 15x disappear, and 5 take away 30 gives minus 25, and that's the remainder. So the answer is x squared minus 6x plus 15, remainder minus 25. Now in part 2, we're asked to get the remainder using the remainder theorem. So if we only need the remainder, what we can do is we can substitute x is equal to minus 2 into the original cubic equation. Now that gives us minus 2 cubed minus 4 times minus 2 squared plus 3 times minus 2 plus 5, which is minus 8 minus 16 minus 6 plus 5, and they add up to give minus 25. So we see both methods give the same remainder. In another example, find the remainder when x to the fourth plus 4x cubed minus 5x minus 6 is divided by x plus 2. Well, all we have to do is substitute minus 2 in the original polynomial. And that gives us minus 2 to the power 4 plus 4 times minus 2 cubed minus 5 times minus 2 minus 9. Well, that's 16 minus 32 plus 10 minus 9, and that's equal to minus 15. So the remainder is minus 15. In example 3, we're given that when x cubed plus 6x squared minus ax plus 7 is divided by x minus 3, the remainder is 4. Find the value of a. To solve this, function of x is equal to x cubed plus 6x squared minus ax plus 7, and we also have function of 3 is equal to 4, because when we divide by x minus 3, the remainder is 4. So 3 cubed plus 6 times 3 squared minus a times 3 plus 7 is equal to 4, or 27 plus 54 minus 3a plus 7 equals 4. So 88 minus 3a equals 4, or 84 equals 3a, and so a is equal to 28. And that's our answer. A is 28. Remember, when function of x is divided by x minus a, the remainder is function of a. Now, there follows an exercise. You can pause the video at this point and have a go at it yourself. When you've tried it, you can restart the video to check your answers. Okay, let's go through the solutions. In part 1a, we have a cubic polynomial which is divided by x plus 2, and we want to find the remainder. So we substitute minus 2 into the polynomial, and that gives us minus 2 cubed minus 5 times minus 2 squared plus 3 times minus 2 minus 7, which is minus 8 minus 20 minus 6 minus 7, which is minus 41. So the remainder is minus 41. In part B, we have a cubic polynomial which is divided by x minus 3. So to get the remainder, we substitute 3 into the polynomial. That gives us 3 cubed plus 4 times 3 squared minus 9 times 3 plus 3, which is 27 plus 36 minus 27 plus 3, which is 39. In part C, we're dividing the cubic polynomial by x minus 2, so we substitute 2 into the polynomial, and that gives us 3 times 2 cubed minus 4 times 2 squared plus 5 times 2 minus 3, which is 24 minus 16 plus 10 minus 3, and so the remainder is 15. In part D, we're dividing the cubic by x plus 1, so we substitute minus 1 into the polynomial, and we have 2 times minus 1 cubed plus 5 times minus 1 squared minus 4 times minus 1 minus 8, which is minus 2 plus 5 plus 4 minus 8, which gives us a remainder of minus 1. In part E, we've got a cubic polynomial divided by x plus 3, so we substitute minus 3 into the polynomial. And that gives us the remainder is equal to minus 3 cubed plus 5 times minus 3 squared plus 3 times minus 3 minus 4, which is minus 27 plus 45 minus 9 minus 4, and so the remainder works out to be 5. And in part F, the cubic polynomial is divided by x minus 1. So we substitute 1 into the polynomial, and the remainder is 4 times 1 cubed minus 6 times 1 squared minus 8 times 1 plus 2, which is 4 minus 6 minus 8 plus 2, and the remainder is minus 8. In question 2, the polynomial x cubed minus 3x squared plus ax minus 7 is divided by x minus 2 and has remainder minus 1. We're asked to find a. Well, if we substitute 2 into the polynomial, we get 2 cubed minus 3 times 2 squared plus 2a minus 7 is equal to the remainder, which is minus 1. And so 8 minus 12 plus 2a minus 7 is equal to minus 1. Or minus 11 plus 2a is equal to minus 1. And if we add 11 to both sides, we get 2a is 10, so a is equal to 5. In question 3, we're told x cubed plus 4x squared plus 5x plus a, when divided by x plus 1, gives a remainder of 4. So if we substitute x is equal to minus 1, we have minus 1 cubed plus 4 times minus 1 squared plus 5 times minus 1 plus a is equal to the remainder 4. So minus 1 plus 4 minus 5 plus a equals 4, or a minus 2 is equal to 4, and so a is equal to 6. In question 4, we're told that when the polynomial is divided by x plus 3, the remainder is 20. Now that tells us that minus 3 cubed plus a times minus 3 squared minus 7 times minus 3 plus 8 is equal to the remainder 20. So minus 27 plus 9a plus 21 plus 8 is equal to 20. Now that simplifies to 2 plus 9a equals 20, or 9a equals 18, and so a is equal to 2. In question 5, we're told that when the cubic polynomial is divided by x minus 4, it has a remainder of 15, and we want to find a. Well, if we substitute x equals 4 into the polynomial, we have 2 times 4 cubed plus a times 4 squared plus 6 times 4 minus 9 equals 15, or 128 plus 16a plus 24 minus 9 equals 15. That simplifies to 16a plus 143 is equal to 15, or 16a is equal to minus 128. That gives us a is equal to minus 8. In question 6, we're told that when 2x cubed minus 3x squared plus ax plus 9 is divided by x plus 2, the remainder is minus 11. So we substitute x equals minus 2 into the cubic polynomial. And that gives us 2 times minus 2 cubed minus 3 times minus 2 squared plus a times minus 2 plus 9 is equal to minus 11. And that gives minus 16 minus 12 minus 2a plus 9 equals minus 11, or minus 2a minus 19 equals minus 11, or minus 2a equals 8, and so a equals minus 4. In part 7, we're told that when we divide x cubed plus 5x squared plus ax plus 7 by x minus 1, we have a remainder of 9. And we're asked to find a. To do this, we substitute x equals plus 1, and this gives us 1 cubed plus 5 times 1 squared plus 1a plus 7 is equal to 9, or 1 plus 5 plus a plus 7 is 9. In other words, a plus 13 is equal to 9, which gives an answer a equals minus 4. In question 8, we're given the polynomial x cubed minus 3x squared plus ax plus b, and we're told when it's divided by x plus 2, it has a remainder of minus 10, and when it's divided by x minus 1, it has a remainder of 23. We're asked to find a and b. Well, if we substitute in x equals minus 2, we'll have a remainder of minus 10. So minus 2 cubed minus 3 times minus 2 squared minus 2a plus b is equal to minus 10. So minus 8 minus 12 minus 2a plus b is equal to minus 10, or minus 2a plus b is equal to 10. Now also, when it's divided by x minus 1, it has a remainder of 23. So if we substitute in x equals 1, we'll get an answer of 23. So 1 cubed minus 3 times 1 squared plus a plus b is equal to 23, or 1 minus 3 plus a plus b is equal to 23, which tells us a plus b is 25. Now we have a pair of simultaneous equations. A plus b is equal to 25 and minus 2a plus b is equal to 10. So if we subtract, we have a take away minus 2a, which is a plus 2a, or 3a. The b's cancel, and 25 take away 10 is 15. So 3a equals 15, or a equals 5. Now if we substitute a equals 5 in a plus b is equal to 25, we get 5 plus b equals 25, so b equals 20, and that gives us an answer. A is 5 and b is 20.